The next ones, limiting reagent, excess reagent, are the more complex ones, but we're still going to follow some basic things that we did before. We still have to follow some basic guidelines like write and balance the equation. We have 21.4 grams of aluminum reacted with 91.3, reacted with iron 3 oxide. That is not 3 irons, that's Fe2O3. It's a kind of iron with a +3 charge. That's going to make aluminum oxide, Al2O3. And it's also going to have iron as a product. Classic single replacement reaction. Balancing this is going to require 2 aluminums to match the 2 aluminums over here, and 2 irons to match the 2 irons over there. There we have it all balanced. So we're following the same steps, right? And balance the equation. When I start to read this, this is where it sort of differs. What I was given, there's going to be 2 givens. They'll have numbers on this one. And so I kind of have to identify both of them. Given 21.4 grams of aluminum, 91.3 grams of iron oxide. What they're going to be asking about is the mass of the different color. Iron will be produced. They want to know about iron. So there's going to be more than just 2 important boxes. They're going to tell us how much aluminum. They're going to tell us how much iron 3 oxide. They don't really care about this one, although it'll start with 0. This will start with 0. And what they're going to be asking about is how much iron can we make with only that amount of products. So I balance the reaction. I've read through it to figure out what it is I want to know and what it is I'm given, and I've identified my important boxes. Next step is going to be convert to moles. 21.4 grams of aluminum. 1 mole of aluminum, according to the periodic table, is 27 grams. So we have 0.8 moles of aluminum. So let me just write 0.8 moles of aluminum. The other reactant, 91.3 grams of Fe2O3. 1 mole of Fe2O3 is 159.6 grams. That's adding up 2 irons and 3 oxygens. That's going to equal 0.57 moles. 0.57 moles. The next step is, in a limiting reactant, we have to do 2 mole ratio calculations to find how much iron. 2 given numbers. Find how many moles each can make. So I'm going back and checking my same mole ratios. How about aluminum? 2 moles of aluminum results in 2 moles of iron. That's a 1-to-1 or 2-to-2 ratio. So 0.8 moles of aluminum can make, theoretically, 0.8 moles. I'm going to draw a little line there, though. I now have to figure out what about my iron 3 oxide. 1 mole of iron 3 oxide will make 2 moles, twice as much. 0.57, here's some scrap paper, 0.57 times 2 over 1 equals 1.14 moles. So I have enough aluminum to make 0.8 moles. I have enough iron 3 oxide to make 1.14 moles. Well, that means I can only make the smaller number. So the next step, circle the smaller number. That's how much we can make. Cross out the bigger number. We won't be making that today. There's not enough. I could just write circle smaller number. Cross out larger number. You can write it however. That might be how I might remember it. Okay, so this has got me on its way. So step 1, well, we haven't answered any of the questions yet. They want to know what mass of iron will be produced. They want to know the limiting reagent and the excess reagent. So here's how I determine limiting and excess. How come I can only make 0.8 moles? That was limited. I put that on the left because that was my first one. That was limited by the aluminum. So my limiting reagent, it's the aluminum. That means I'm going to have excess iron 3 oxide. If my limiting reagent is aluminum, I'm going to use it all up, minus 0.8 moles. When I'm all done, I'm going to have 0 moles left. I'm not going to use up all of my iron 3 oxide. I'm going to have some extra. Now I'm going to try to determine how much extra. So I'm going to use this number to figure out, since I know I'm limited, I'm only going to make 0.8 moles, I'm going to figure out how much iron 3 oxide I have to actually use. So I check the mole ratios. If 1 mole is required to make 1 mole of iron 3 oxide is required to make 2 moles of iron, then 0.8 times 1 over 2. I'm using the mole ratios. I'm using the coefficients from the balanced equation. I'm only gonna need half as much, which is 0.4 moles. So if I started with 0.57 and I subtract a 0.4, I'm going to have 0.17 moles of leftover left. Okay, so far I've identified the limiting reagent, I've identified the excess, I've even figured out how much iron and how much extra I'll have, but they're all in moles. So the last step is to convert all these moles to, this asks for mass, this asks for mass. What mass of iron? I'm making 0.8 moles of iron. 0.8 moles of iron times 1 mole of iron is 55.8 grams. That's going to equal 44.6 grams of iron is going to be produced. Make a nice little thing here that lets people know, yep, this is the answer. That one last thing, I have to figure out how much excess reagent. If I have 0.17 moles of Fe2O3 left and 1 mole of Fe2O3, and on top I'll write its molar mass, 159.6 grams. That's going to equal 27.1 grams of Fe2O3 excess. Check my labeling. It just makes it clear, if the teacher was looking at this quick, of which numbers meant which, how much iron was produced, how much excess.